So let's look at a quick example to put some numbers on this, the mole fractions being different in the solution versus the vapor. So let's consider a mixture of 1 and 2 propanol. Again, two molecules that are very similar and so form an ideal solution. Right. Again, we've just moved where the alcohol group is in each of these, but they have the same number of carbon atoms, and et cetera, et cetera. So if we are considering 25 degrees Celsius, right, so temperature 25 degrees Celsius, we can look up what the vapor pressures, if we say, we call this one 1 and this one 2, which makes sense. We can look up the vapor pressures of the pure substances at 25 degrees Celsius, which for 1 propanol is 20.9 torr, and for 2 propanol is equal to 45.2 torr. Okay, and so they have different vapor pressures at the same temperature. And so if we're given let's say that we know we have a solution that is has a mole fraction of 0.75 in component 2, in this case 2 propanol. So there's 75% of the molecules are 2 propanol, 25% are 1 propanol. What's the total vapor pressure, and what is what we'll call Y2? This is the mole fraction in the vapor. X represents the mole fraction in the solution. Okay, and so we have all the information we need. Okay, so P total, well, we can find the vapor pressure of each one, right? So we know that P1 is equal to X1 P1 star. Okay, and then we can plug in specific values here. We know that X1 is 0.25 in this case, right? No units on a mole fraction. And then we multiply that by P1 star, which is 20.9 torr. All right, and that's pretty straightforward. Let me just pull up my calculator real quick. I don't have this already calculated. Okay, so we have 0.25 times 20.9 gives us, oh, have an extra 5 in there, equals 5.23 torr. And P2 is equal to X2 times P2 star, which is equal to 0.75 times P2 star is 45.2 torr. All right, so 0.75 times 45.2 is 33.9 torr. So if we add those together, we'll get P total. All right, and that will give us 39.1 torr. And that is just adding these two values together. Okay, so that's pretty straightforward. Now the other question is, what's the mole fraction of Y2, right? And we can look at what we need to remember is that for ideal gases, we can say that the mole fraction of X1, sorry, I should say Y, the mole fraction of component 1 is simply equal to the partial pressure of component 1 divided by the total pressure of component 1. Okay, and so we can just plug in our values here. We have 5.23 divided by 39.1. And these are both in torr, but the units will cancel here. And if I go ahead and calculate that, 5.23 divided by 39.1 is equal to 0.13. And we can do the same thing for Y2. It's going to be P2 over P total, which is equal to 33.9 torr divided by 39.1 torr. And we should get 1 minus Y1. We'll just double check that that's true. 33.9 divided by 39.1 gives us 0.867, or 0.87. which indeed, if you add these two together, you get 1, as you should. And the thing that you can notice is that if we compare these to the solution mole fractions, right, this one was given as 0.75, which means that this one was 0.25, we see that these are not the same. We see that we get a significantly higher fraction in the vapor of our more volatile component, right? P2, 2-propanol, has a higher vapor pressure, so therefore we get more of it in the gas phase. So because we get more in gas phase, the vapor is enriched in 2-propanol. We can take advantage of that fact, and we'll look at how we can do that to separate out these two substances by using distillation.